Okay. First things first, does anybody have any questions with regards to the homework before we get started? It's due Sunday right now. I might extend it a little bit because we do seem to have a little bit of time, so I might just kind of try to spread 4 and 5 out evenly. Okay, for sure. If anybody has any questions, let me know. One thing I did want to mention about assignment 4, I can put these up on Canvas. I hadn't before. They're in the Discord though. I had posted them because I had gotten some questions from some students. It's taking a second to open, but I put 2 images just explaining like the general kind of approach for the one of the board solutions, and so I think that might be a little helpful if you want to take a look at that if you get stuck. By all means, if you think of your own solution, just feel free to use that. I just wanted to provide a kind of like easy solution. Really, I think the solution I gave is something like 4 or 5 lines of code when you actually implement it with the way that I wrote it out with math. So definitely recommend that one if you're stuck. If you have any questions about the methods, just let me know. There's a bit more math in assignment 4 than some of the other assignments, so it's more so understanding the actual like math approach more so than the programming. I think is the tricky part of that assignment. But the other administrative note is that I think last class I said that the exam is going to be 2 weeks from now, either October 5th or October 7th, and I did confirm it. It should be October 6th and 7th for this class. Since we're on a Thursday, it's going to be the second one, October 7th. So our first midterm is on October 7th. 2 weeks from today, exactly. And again, this will cover everything up to virtuals that we've done now. And we'll have a review the Tuesday before that. So October 5th, we'll do review. And please, if you have questions, please feel free to bring them in, and we can definitely go through those. If not, I'm just going to go through a bunch of different topics, I guess, and kind of try to get an idea of what everyone wants to go over. So question, how will the exam be structured? It's going to be, we haven't finished making it yet, although I have been going through, because I'm helping a little bit with making the exam. I've been going through and kind of looking through the questions and trying to get an idea of what's on it and what kind of format we want it to take. I think it's probably going to be about 20 questions or so. If I imagine, it'll be a mix of kind of multiple choice questions and then essay questions, and then there's always one programming question, so you'll be asked to maybe write a 20-line program. The multiple choice ones, I say they're like multiple choice-esque because it's not going to be A, B, C, D. It's more so going to be like, here's this certain condition, select all that apply. Like, I don't know, if it was something like this. It might be something like select all that represent the address of X. This isn't an actual question. I was careful about that. So I might ask, like, out of these 4, it'll be a kind of multiple choice. Which ones of these expressions would represent a address? And then you would pick all that apply. So in this case, it would be something like, well, that one's an address, and this one's an address. And so you'll be marked based off of those. So it'll be a combination of those and free response questions. The free response range anywhere from definitions or just general like knowledge of programming to questions that may ask you to fix code. So there may be errors, or it'll ask you to expand upon the code, or it'll ask you to write maybe like 3 or 4 lines of code. They're generally not too long. they're also going to be randomized for every single person who takes it for all sections. So everybody's going to have different questions to prevent cheating. We're doing that in place of the, what's it called? Lockdown browser that you may have used in other classes, because it's bad. Not only do I not want to, spy on anybody, but that program is just, it's not good. It like locks you out of certain things on your computer, and it's really hard to remove it. It's basically just malware that we pay for, in my opinion. But yeah, we're going to avoid that by randomizing everybody's question sets. Yeah, root access, right? I had to use it for one of the courses I'm taking, and I can't power off my computer anymore. I have to like hold down the button on my laptop. It just won't turn off. You could run lockdown in a VM, that is fair. That's probably a smart idea, although I'm sure it would run kind of slow. Plus, there's like security vulnerabilities in it on top of that. Like, I'm not going to say how, but there are ways to run programs that you're not supposed to be running when you use it. So, yeah, anyways, we're going to avoid that. We're just going to take a test like normal, but we're just going to write enough questions that it's going to be hard for people to cheat. And plus, I usually Google, if your answer seems suspicious, I will Google it and see if you got it from a website. So don't do that. And other thing to mention, it will be during the normal class time, so it'll be at 5:30 to 6:45 on a Thursday. You'll have about an hour and a half to take it. I will probably extend the time a little bit beyond class time, just in case anybody has some sort of obligation. Maybe have a little bit more buffer time, but please expect it to be at the normal class time. Okay, I think that's about it for administrative stuff. Any last questions on the exam at all? If I have time, I'll try to put up review questions as well. At least I'll put up a topic list at bare minimum. All right, cool. Don't see any other questions. So let's get back to what we were doing last class. I want to finish doing some of these operator overloads. I implemented 2 of them already just because I feel like they were pretty similar to the plus, and I didn't want to have to take time to do that again. But I want to cover some of the other ones that are a little bit more different. So remember last class, we had this matrix class that was basically like a matrix from math, where we have a 2D array with rows and columns, and then we have numbers inside of it, and we wanted to make it so that we can do operations like you would see in math. And we said that you could normally do that with just a function, so I could make a function called add matrices or something like that, make it static, and possibly put it outside of the class. I guess it doesn't really matter, you could do it either way. And then I could just, type add matrices, matrix 1, matrix 2, and have it work. And that's totally fine. That works, and that's no different from what we're going to do. But we said that sometimes when you write mathematics or other things, that there's some implied meaning when you do an operation, or the data can take on multiple forms. So we went back to that whole polymorphism stuff. And so we said it was like, okay, well, I could just write like matrix 1 plus matrix 2, or matrix 1 times matrix 2, and that just looks nicer. And the solution to that was just operator overloads allow us to write things nicer. And that's it. That's the only application of them, is that they're just nicer to read. And so this plus and this times that we wrote are just special kinds of functions rather than just doing this operation normally. What C++ does for all operations actually is it just calls a function based off the operation. And the way that you name those is operator overloads. So here we had 3 functions for adding 2 matrices, subtracting 2 matrices, and multiplying 2 matrices that all return a matrix. And these were all static, and the way that we mark them as static is we make them friend functions. So remember, there were 2 different ways we could implement this in C++, but generally the commonplace way for most operators is to make it a friend, at least for your standard operators like addition and subtraction and all the math ones. And what this means is that it's like almost like a global function. It's out there on its own, but it's a friend to this function, which means that it has access to private variables. So that's what a friend meant. It's just a normal static function, outside of the class that has access to class members that it normally wouldn't if it was just written normally. So here we have plus. Notice there's no matrix colon colon in front of it, meaning it's just its own function that exists out in global space. And it returns a matrix. It takes the two matrices and it's a plus. But it also has access to private variables like columns and rows, and it has access to that when it's marked friend. And so last class we wrote plus, and then I just copy and pasted minus and times from the code I wrote earlier. I fixed times, so it should work now, and I'll upload this on Canvas later. And we'll take it that it works. I tested it before, and I think it's fine now. So that's okay. But we said that this is the way that we would do like math operators. And so I want to do a few more operators. I do want to do one more math operator first, just to show a bit of a difference here. So remember that in math, when you have matrices, for the sake of simplicity, I'm just going to start writing these as variables. I have a matrix A that's like this, and I have a matrix B that's something else. Then I have the ability to do that, and it gives you, let's just say, some matrix C. So I can multiply two matrices. I can multiply them in different order. So remember, this is something that we'll just kind of keep in the back of our minds, is that operations are not commutative all the time in math, and in programming it's assumed that they're not commutative by default. So remember, oops, this should not be C. Like A times B and B times A, when you multiply matrices, sometimes one way works and the other doesn't, and if they both work, either like both square matrices, then they don't usually give you the same answer. So it's not commutative. You can't like flip the order of doing operations. And the same thing applies when we write our functions, because they're like dependent on a parameter list. So we have that issue. But on top of that, in math, you can also use multiplication with a matrix and a number, like scalar, and it would just be like 3 times all the numbers. So this, for instance, would be the 3, 4, 5, 6 times 3, so it would be 9, 12, 15, and 18. Just as a reminder for your math. And what I'm proposing is, let's go ahead and try to write this one as well. And the point being that we can do multiplication with matrices that return a matrix, but take different parameters. In this case, these first two are a matrix times a matrix, which gives you a matrix as your answer. And then the second one is a scalar or a number, which we're just going to implement as a double, times a matrix, also gives you a matrix. And you can use this operation on things and have it mean different things, even though they belong to the same class. So it's really quick. Just go ahead and write this. Let's do that there. And then for this modification, let's make it so that instead of multiplying two matrices, it takes a double. We'll just call the scalar, and then multiplies it by a matrix. Let's just call M now that we only have one. And this should be really quick to implement, so I'm just going to throw this at the bottom. And I don't need to put friend outside. There we go. So really just need 2 for loops. I suppose we do need a separate matrix. As a tip for writing these kinds of functions, I almost always recommend that you make a separate variable for your result, and that you don't try to modify whatever parameter it is that you're taking. Or if you do this as an instance version of this, that you don't do it on this object. Most of the time, I think that's a bad idea. So I'm going to make a copy here. I'm just going to call it result, I guess. That way we can not modify our thing when we multiply it. If we wanted to have like an equivalence thing for this with what we know so far, then if I did this, y equals 3 times 5, I would argue that, oh, whoops, not 3 times 5, x times 5. I would argue that this should not modify x, so after this line, y should be 15 and x should be 3, and that you shouldn't update x to 15 because I think that's kind of not what's expected behavior. Just be careful when you're programming these. Don't modify this. When I say that, I mean like this object. If I was to call this multiplication operator overload, it would call it on the number x, and x would be this. By this, I mean the keyword this that you write. So just make sure you're not modifying this numbers, because that will modify it mid-expression, which is probably not the intended behavior. Like you wouldn't expect x to be 15 here halfway through the expression. Just y. Anyways, that's why I do the extra result, is so that we don't overwrite the thing that's calling it. So we have I is equal to 0, I less than height, I plus plus. Sorry, I called it rows and columns. M dot rows, and for j equals 0, j less than m dot columns, j plus plus. I probably need to actually tell it how big this one is with the constructor I wrote. So we'll just tell it has the same amount of rows and columns as the original matrix our result is going to have, because when you do multiplication with matrices, then you just do multiplication like element wise, so the size of the matrix doesn't count or doesn't change when you do a scalar. And then we can just do result dot set value, and then we want row and column. In this case, the row is I, the column is j, and the value will be the scalar, whatever that is, times the matrix dot get value of I, j. And now if we write this with these different operators or different operands, then I'm able to now do something like this in main. I suppose I can't have a dot. And I could print this. And there we go. Now we can multiply a number by a matrix. Does print matrix take something? Oh, right, the stream. And we can assume this works. I could run it, I guess. But now we have the ability to run this and have different kinds of operations. So multiplication with a matrix can mean a multiplication. Oh, I think I forgot to return. We'll fix that. It can mean multiplication between a number and a matrix, and when I write times, it can also mean multiplication between a matrix and a matrix, depending on how I decide to use it. And I forgot to put a return at the end of my function, and that should fix it. Now, one thing I'm going to ask is, we've written this now so that there's multiplication defined between a scalar being a double and a matrix. If I was to write this backwards, and I'm going to comment it out, is this going to work, and why or why not? I kind of gave a hint earlier. Right, so I see 2 no's, and you guys are right. This is not going to work. And that's why I commented it out. It's going to have a red squiggly under it. And I did see the reason as well, and it's because of the parameter order. So we have a scalar and then the matrix, and then a matrix and a scalar. And even though we know that this is fine mathematically, like you could write those backwards, even though it's not common, that's totally fine, it would work. Our parameter order to our function is scalar and matrix. And I bring this up because this loops back to our commutativity part, is that the compiler assumes no commutativity by default. So it's not just going to flip the parameters for you and make it work, because it doesn't necessarily know that that's allowed. So if I wanted to also make this be allowed, I would need to go and write a second friend function where the order is matrix m, then scalar, and basically write the same code or just call this version of it. I'm just going to leave it as is, but I want to bring that up. So it's not commutative. It won't just fill that in for you. If it's commutative, you're going to have to write both directions. Cool. So I think that covers all the math stuff. Any questions on those so far? We'll do some of the computer related ones like programming language operations next. Okay. So let's do one more. I was considering doing equals equals, but I think I'm going to skip it. I think let's just do equals. So we have the assignment operator, equals, and this is built in for you. Normally this happens. So if I wrote this code matrix M0 and M1, and then let's just say I populate them somehow. And then I go to use them. And I say M0 equals M1. We discussed at the very end of class last time that there was an issue with this. Does anybody remember what that issue is? I'm just going to start to draw it out, but feel free to stop me. Does anybody remember what the issue with this thing is? By default, like what's the issue with having it do the default equal where it just copies everything? Right, you got it. The addresses will be the same if we're using pointers. In this case, we have M0 has its array, which is pointing to some 2D array in memory. And then this one's pointing to its own array, which may be a different size. And then they have their own rows and columns. And something like that is fine because these are values, they're not pointers, and copying them is totally okay. But when we're using pointers, it will copy the pointers via value, meaning that it copies the addresses that these represent. So let's just say this one was address hex A, 0A, and this one was hex 4B or something like that. Then if I do this line right here, what it's going to do is it's just going to overwrite all of the stuff in M0 with the stuff in M1, which is fine for rows and columns. Let me just erase columns so we have some space here. So I can have, let's just say M1's rows are 3 and this one was 2. So actually, I guess, sorry, other way around. This one was 3 by default and this one was 2. And when I go to copy the contents of M1 to M0, because that's what this line says to do, it's going to overwrite this with the number 2, which is fine, like if we wanted to copy the array over. But when we go to copy this thing over, what it does is it just copies the value directly stored in the array variable, which is a pointer, not the array itself, meaning that it's going to copy over the address 0b, and now they're pointing to the same thing, which leaves us with two issues. One, now that they're pointing to the same thing, we're going to have an issue where if I update one of these matrices, it's going to also affect the elements of the other one. So they're stepping on each other's toes and writing to the same memory, which we don't want. And then we also have the issue of we no longer have a pointer to this matrix that used to be here, this red one, because it just copied that over and didn't do anything about it. And that means that this matrix is now lost to us. It's a memory leak. So we have two issues there, and we want to avoid that. In the case that you have classes with pointers in them, it is a good idea to try and write an equal overload to avoid this. And that's what we're going to do. We're going to write that for the matrix class to make sure that we can avoid the memory leak and then also make a copy of this array rather than have them point to the same place. And the other thing I was going to mention, which we talked a little bit about last class, is if I was to do an equal overload, is that, again, the compiler is going to give you a default equal sort of thing, but it's going to check based off of pointers, not based off of values. So if we wanted to write an equal overload, which I'm not going to for the sake of time, you need to check all the contents of the array and not just use the built-in equal because it compares these R parts as well. It'll actually check those pointers. Or potentially, depending on the implementation, it might just check the pointer of M0 and M1 where they are. I don't think that's how the C++ equal works by default, but that is how it works in other languages because they keep pointers kind of hidden from you in other languages, and they just compare those instead. But anyways, let's go ahead and try to write our equal overload. And actually, one thing to note is even though I've been using equal here so far, it's actually been okay. So this is one scenario where it's all right. And the reason being is because I'm not actually copying a variable directly. I'm copying an expression. And remember, we said that this is like a function call. It represents a different matrix based off the way that I was implementing them, right? I declared a variable called result that was a separate matrix. So with my current implementation, we don't actually have that memory leak. It's totally fine. And if you only expect to do this, it's actually probably a good idea to not write the equal overload because it's totally fine. But we are going to do it anyways because we kind of want the practice. Now, I would still argue that if you write any kind of equal expression, that you make it void returning, except for equals, that's Boolean returning. Because I would say that equal has no inherent value. I don't believe you can write this one as a friend function. I think it will tell me you can't. Yeah, it says must be a member function. So this is one of those exceptions. There's another one we're going to write in a second that's also the case. Some of these can't be friend functions. Some of them have to be friend functions. This is one of the ones that can't be. Too many parameters. Oh, right. And so that means that I'm only going to have one parameter. So this goes back to the instance one. When I write this equal overload, it's going to take one operator, or one operand, being the matrix on the right-hand side. The one on the left-hand side is implied to be this matrix, the one that's calling it. So I'm going to use this to refer to that. And I'm going to use this other to refer to the matrix on the right-hand side of the equal. Let's go ahead and write that down here. This needs to be a matrix operator for this one. And then we'll write that. So the first thing we want to do is we want to avoid doing the memory leak that we just had. So we should check first to see if our array is already allocated. Which I think we were just keeping track of if the array was not equal to null pointer. I think there's no way for that to happen in the code that we've given so far. So that's probably fine, but I wrote a function in between classes just called deallocateArray. I won't go through it. It's talked about in the assignment 5 video if you're curious and want to jump ahead a little bit about that. But I'm going to provide the code anyways on Canvas if you need to see it. And then, okay, so that avoids the memory leak. If we have an existing array, then just deallocate it, and then we need to copy everything over. Which means we need to copy the rows. We need to copy the columns. And then we need to copy the actual array itself. And because we deallocated the previous one, we're going to need to allocate this new one. Again, Again, I wrote a function last class called allocate array, and the width is going to be the number of columns that there are, and the height is going to be the number of rows. And then we need to copy everything over. So this will just be the 2 for loops again, where they just go into the same position. I think I've mentioned this before, but you should always try to write your loops over 2D arrays in this order: rows first, columns second. It's more efficient, and the compiler will actually correct you if you do it backwards. It will fix it. Generally. I think there's some cases where it might get stuck if you have like a bunch of different kinds of accesses. We're just going to copy this over. So this sub r ij is equal to the other dot get value ij. And that should be that. I think that error is still from last time I tried to compile. Let's just check if that's the case. So I'm going to do matrix mat5. I think that's safe. Is equal to mat2. And then we will do mat2.print matrix. Just out. Let's print the 5th one and just make sure that it allocated the space and then it looks like mat2. Which I can pull up as well. And we see at the end that it prints a 2x4 matrix, which I think mat2 was. And it looks like it was. So this is the matrix2 files that I had before. It was a 2x4 with those numbers, and it seems to be the same stuff there. So it seems to copy everything over. We could verify it further by maybe multiplying by number and overwriting it or something, and making sure that they don't work. But I'm pretty confident that it works, so I think we're just going to leave it. Any questions on that, or why we specifically should write that equal? And why I'm not just leaving it with the compiler implementation? Okay, so that covers equal. I want to go over maybe 4 more really quick. There's one I'm not going to implement, but I'm just going to talk about. I mentioned it last class, and I tried to do some research because I know there's some weird things about it in C++. There's the ability to override this, which is the function call operator. It allows you to do weird things like this and call it like that. Or I guess I would have to declare it and then call it afterwards. Let's assume there's a variable called m1. In fact, I could just... It allows you to do something like this, or even just leave it on its own, and then you can define it in whatever way you want. So you could tie a function to it that has no name, which is really strange. It's usually used for copying things. Like you can use this as a copy constructor, or a copy, kind of like a constructor. It's not a constructor, but it's a copy call, which I guess I would say you should do that this way. When I say copy constructor or copy call, it's like this, where we copy everything over, but we make sure that the pointers are copied in a different way. One thing, oh yes, sorry, terminology that I have been meaning to mention about this. This approach that we did is called a deep copy. And that's good. You should do that as much as possible. It's less efficient because we had to take that time to actually allocate the space for the copy array and then copy everything over. But it, like we said earlier, it doesn't cause a memory leak, and it also doesn't have that issue of pointing to the same thing. So when we do it the way that we're supposed to, that's a deep copy. which means that you physically make a copy of every single element and then allocate it and do separate things. A shallow copy is what our old implementation was. And the shallow copy is the built-in one. That's the one that means it just goes and copies directly. So this copies verbatim. And this one copies and makes them separate, I guess is the way I would phrase it. So the implementation we did is a deep copy. The shallow copy is the type that the compiler does by default. So just some common terminology. You'll see this used pretty frequently if you look things up with regards to this. So just something to mention. One other note about this is I like to do this with the equal. Although if we had that scenario that I described above where you were content with the way it worked for like the times and plus operator making their own copy and then it just doing the equal and having that copy over, and you wanted to have the other scenario with this equal be separate. So rather than write an operator overload for this, there's another common approach to it, which I'll just mention really quick, and it's called a copy constructor. In general, I would say copy constructors are pretty nice. I would write them most of the time if I was going to write something over an equal overload, but I guess the syntax is nicer, and I think some people prefer it. I'm not really 100% sure why you would prefer it in C++, but the copy constructor is a constructor that takes another object as its parameter. So if I could write a matrix constructor whose argument is a matrix, and then the constructor itself would just do all of the code that we just did in equal a few moments ago, where it copies over all of the relevant members and then allocates any necessary pointers to arrays and then copies that over. That would be called a copy constructor. Basically, you just give it a model of another object to look at and use that to construct it. So it just makes a copy of the thing in the exact same way that we just did the last one, but you can do it in a constructor syntax. Meaning that if I wanted to copy some things, I could make a matrix M0, I could populate it somehow, and then I could make a new matrix M1, ooh, that lagged, like this M0, and it would then make a copy of M0 and store it in M1. So this is a different approach, just called a copy constructor. Cool. So we have that. And then we have this, which some people will also use this like a copy constructor and have this represent making a copy of the thing is a common thing. But from what I was reading online, it's totally possible to make this do anything. And I guess that's a fair approach to how it works. Last class, I mentioned that C++ doesn't support making your own operator, so I can't just do something like this where I say, I want the letter A to mean addition now, and try to define an operator overload for the letter A, because it's not clear how to parse it. It doesn't know how to do that. So it just can't figure out what this means, whether it's like a variable name or something else. So, and it doesn't really work here, but if I had a variable called x, then we see that this string represents a valid variable name, but I want it to mean addition, so it gets a little confused about what that means. This is used in place of that, so you can make this mean anything you want. So for example, if I wanted this to mean multiplying how many ever numbers together, then I could do it like this, 4, 5, 6, and then write a function that takes 3 doubles, let's just say, and multiplies them and returns the result. I don't know why you would ever really want to do this. Maybe it's just comfortable to you. I think it kind of defeats the purpose of an operator overload. I don't see why you just not use a function. It's really just the same as calling a function, but you don't give it a name. I would highly advise not ever using this, but it does exist, so just be aware that it's a thing. And you're ahead of me. So question in chat was, could you overload the extraction and insertion operators? And I am actually about to do that right now. That was the next thing in my lecture notes. So good call. You're right. I'm actually about to do that. I think let's talk about it a little bit before we actually program it. But yeah, let's say you wanted to do this, where you have a matrix and you just want to write it like this way. And by default, the compiler is going to tell you that's an error because it doesn't know what it means to print a matrix. And that's why we wrote the print matrix function before. Now we can write this in a way where it's written like this and just have it print the exact same way. And again, it's nicer to read with C++ syntax if we do that. So we need to consider some things here. This one I think is less obvious than the other ones in terms of implementation for like the parameters. If I did something like this, then hopefully that's obvious that this is a matrix. This is a matrix, and my answer is also a matrix. So this would give me some other matrix. Let's just say mat3. And so the parameters to this one are two matrices, and the return value is a matrix. Can anybody tell me what the parameters and the return of this one is? I think the parameters are fairly straightforward, but the return type is maybe not. So first off, what would be the parameters to this kind of operation? Right, so I see two answers. Stream and matrix and stream and type and OStream and matrix. Yep. So I think you guys are all on the right track. The right side is a matrix or whatever custom type it is that you want. And then the left-hand side is a stream. In this case specifically, you do want it to be an output stream. So I'm going to call it OStream. And it actually needs to be passed by reference. You have to be very particular about that. And the reason it needs to be passed by reference is because when you do a print to a stream, you are modifying that stream. When you do cout and then something followed by it, it has to fundamentally change cout. It can't get a copy of it. And so when you do this, it needs to always be by reference. So I'm going to do an OStream and then that. And the reason you keep it as an OStream is so that you can also do this with files as well, and that's totally fine. And then the second question I have is, what is the return type of this? So what do I get out of this? Which I don't think is obvious at all, but if anybody has any guesses, I'm going to write one more thing to maybe give you a hint. What if I wrote it like this? What would this need to return for this to still work? And you're right, it's an OStream. Yep. Good job. Okay, yeah, that's an OStream. And the reason being is because when we think about what this operator did before, it needs to recursively like have an OStream on the left and the thing to be printed on the right. So whenever we return this, because we might have more things that we need to print afterwards, we need to return the OStream we just printed to in order to have this work. So one way to think about this is, once this is done, I want it to then cout mat2 afterwards is what I want this to condense down to. So kind of like your algebra here, this starts off as cout mat1, mat2. We can apply parentheses, this there, and we need it to reduce to this. So the operation needs to do the printing and then return the operating or output stream that it just printed to, so that it reduces kind of like an algebraic sort of thing. And this is how all expressions are reduced in general when the compiler does it, but we kind of need to consider it when we're doing our thing. Cool. So good job. I think everybody had the right idea in chat there. Saw a bunch of right answers, so that's good. And let's go ahead and try to write this really quick. Should be pretty fast. And then we'll do the input stream as well. It's going to be basically the same thing for the input stream. Same logic applies. We need it to take an input stream by reference, and then the thing that we want to read into, and then we're also going to have it return the stream that it just read from. So I'm going to go to our thing here, and I'm going to replace the print matrix and the read matrix with those two instead. Now these ones, whereas equal is something that can't be a friend ever, it always has to be a member, the stream ones have to be a friend. They can't be anything else. And the reason being is because the left-hand operand is always the one that would call it if it's not a friend. And because the left-hand side is always a stream when you print things or read from a stream, then that's why it has to be a friend, is because it would be in the wrong order. I think the compiler will actually let you do it that way, but then it, again, defeats the purpose of an operator overload because you're now flipping them. So we will return the O stream, and it will be an operator. I think this also needs to be by reference, so I'm going to put a reference there. I think that's right. And the operator would be this one, and it will take a output stream, we'll just call out, and then the matrix. I think that's right. And then we just need to do these ones. Cool. Let's go ahead and write these really quick. Oh, whoops. This one would be an iStream. My bad. Cool. I think that's all right. Let's just go up and copy and paste the print and read functions. I also have a constant. That's fine. We'll just leave it there, I guess. And then these now have to be, now that it's an object, it needs to be m.columns, m.rows, m.columns, and m.array, m.columns. Did I delete the print function, hopefully? I gotta delete these. And then we will write this one. I needed to fix it so that it was an iStream. And that will be our read. And this is why I wrote these functions to take the streams originally anyways, is because I knew in advance we were going to do this. Now this will be m.rows, m.columns, m dot, m dot, m dot. And then the only other thing I need to add to these now is that I need to return the stream. We'll return in there and return out here. And we'll just make sure that these work. In place of using read matrix now, I have the ability to do in file and then put the matrix that I want to read into, which was called mat1. In fact, this is probably easier. 2. T3. And then now instead of print matrix, we have the ability to do cout and then the name of the matrix that we want to print to. And now it's just generally easier to read, I guess, at least by C++ syntax. And then we'll just verify that this works, which it should, hopefully. Really just copy and paste the code. And it doesn't. I wonder why that is. Let me just throw a debug breakpoint here and we'll just check it really quick. But if it is something that seems like it's going to be hard to fix, I guess I'll just do it in between classes. Oh, there we go. So it read that the rows and the columns are set correctly, I think. This doesn't seem to be all the things it needs to be. I think I may have put this in the wrong order, maybe. It takes width and height. That is right. Let me just check one thing, and if I don't get anything out of this, I'm just gonna fix this later. Oh, I need to set a breakpoint, huh? Temp is 4.0. This was for the first array, I imagine, which is not one I have open. So it'd be 3, 2, 4 would be the first number, and then the next number would be -3. Maybe it's because of the way that I'm reading now. Next number is -3, 5, that. And I guess the last one, 1? -5? I don't know where it's... Oh, these must be for the next call. I see. So maybe it's something with my print is just messed up. I will have to figure it out later, I guess. But hopefully everybody gets the idea that you can do this now, and those are the arguments that it takes. Again, I'll fix this before I put it up on Canvas. There was one last overload that I want to do. Which was the indexing operator. And you've already used a class before that does this. I think we mentioned it last class. Remember that you had the ability to use a vector, which was its own custom template class. You can fill it with something like this. And then you had the ability to do v.pushback. Let's just say 4, and you could do v0, and it was fine. So with the vector class, you have the ability to use the square braces like you would with an array. That's also something that we can overload, and you can actually make it take things that aren't integers if you really wanted to. I could write my own custom class. Let's just say it has a variable a, and I could make it take strings instead as a lookup to get things out of the array. if you really wanted to. In fact, that's probably how a dictionary works. I'm not sure what they would call it in C++, but there are certain data structures other than vectors that you can access using things that aren't integer indices to look up the things. So you have the ability to do that, or to actually do multiple of them if you really want to. In this case, we're going to do an integer because I think that makes sense. But let's go ahead and write that in a way for our matrix where we can access it using the square braces instead of just using the get value and set value. This one is another one I think that can't be a friend. We'll try it first. I need to give it a type. I'm going to have it return the whole row, like a pointer to a row, which is maybe going to seem weird at first. I'll try to justify myself later. I think this one can't be a friend. Yeah, it must be a member function. So I guess this is another one that can't be a friend. We'll go ahead and write this. This one's really easy. It's just one line. And it's going to be return array sub index. And this needs to be a member, so I guess I got to do this. And I could put this in place of the get value and set value. I'm probably just going to leave those because we'd have to rewrite a lot of code. And I just want to avoid that. But we can see here in main, if I wanted to, I should have the ability to go to, let's just say, matrix 1 and access 0, 1. And hopefully that will print here. Hopefully our read isn't that broken. It threw something. That's not good. Is matrix 1 not big enough that I can do that? That's weird. Something must be happening to my matrices between them being read and redoing stuff. Because it seems to have just deallocated everything. Very weird. Out of curiosity, let me just throw a quick breakpoint here. Yeah, something's wrong with my input. Maybe it's because I'm not passing it by reference. Maybe that's my issue with these. Let's see if that fixes it really quick. I suppose it doesn't need to be for the output operator, just for the input. I guess that makes sense because the input should overwrite the thing that it's reading to. Or maybe I would just need to mark it with a const. I guess we'll see. Now we see that Mat 1. Okay, so I think that fixed the bug that we had earlier. Yeah, these seem to be printing okay again. We see that there's a stray -3 at the very bottom, which I think was from matrix 1, which I'm not printing at all, but we have the file here. So it was getting position 0, 1, which is in fact -3. The point being here is that you can write it so that you have a custom class that's able to take an indexing operator like you would write an array. The reason I've done this as a double pointer, and I can't really do it as just a single integer or like as two separate functions or anything like that, is because I want it to get elements. Remember the way that the dynamic allocation worked is that it was something like this, which was a table of pointers. We had a double pointer called R. Here's a double pointer, and then each of these things were double pointers to arrays. So by making my indexing operator return the pointer to this array, I can have it, let's just say if I had to do 0, 1, it would return this row, and then after that the next indexing operator would grab this thing. So I have it return the entirety of the row rather than just the thing, which allows me to then use the next indexing operator in my code to then access that array. So this part right here, this is our operator overload, is just the first index. It goes and grabs the array at that row, and then the one after that evaluates that index for that row. So this hops to the first position in the 0th row, which lets me use it like a 2D array, kind of, at least in my syntax. But it's just an extra convenience thing if you want it. And I think that covers all the major operators. There's, of course, others. You can do XOR, and all the bitwise operators are also overloadable, but that's just kind of up to you what you think reads the best, because again, this is just entirely for readability, just to make your code look nicer is the only reason you would write these. And believe me, it is actually helpful. I know it just might seem a little superficial, but when you're writing big programs, particularly in machine learning, I think this is very helpful because you do a lot of matrix multiplication and it's just easier to read. Or anything else really. If you're just translating your notes from math to computer science, like programming, then sometimes it's just easier if you read it this way to follow along. And that's the reason it exists. Any final questions on operator overloading, or the syntax of these, or the return types at all? So question, is there a case where you would put your overloads in a define if that's possible? It's possible. You can definitely do that. I can't think of anything super practical for that, unless you're doing debugging, but with an operator overload, generally that's probably going to be something that you implement for something substantial. So I would imagine not, but it's totally possible. You can do that with any kind of function declaration. You can put it in a preprocessor define if you want to get rid of it for whatever reason. Maybe there's like some sort of efficiency thing. Generally, I would say that's for debugging, though. If that answers your question. In fact, you could kind of... No, I was going to say you could kind of do that if you wanted it to have multiple functionality, but I don't think that necessarily works. I guess one possible practical application would be if you needed it to do different things on different platforms. Like you'll see in assignment 5 I wrote, there's preprocessor directives that handle making the console not update as quickly, and the functions for that are different on Windows and Linux, so I guess you could potentially do that, but that would be kind of niche. But I guess on that note, we have about 10 minutes left. I wanted to go over a few more memory management things that I had noticed when going over the tests over the weekend that I just wanted to bring up so that everybody has an idea about them and you don't just get blindsided by the exams. There's just a few things that I think we've gone over the concepts, but I didn't use the technical terms. And so I think it's important that we talk about that. We've talked about memory leaks before, where I have a pointer to something. Let's just say I keep a integer pointer called r, and I set it equal to a new int 4, then we know that a memory leak is something where this will go point to some space, being an array of 4 things, And then if I don't deallocate it before I overwrite my pointer, then I'm going to have some issues. Like if I allocated a new array that was too long and put that here directly, then array goes and points to this and we lose access to that, and that's called a memory leak. But there's also another kind of thing related to this, or similar to this, called a dangling pointer. And this is the scenario where instead of losing access to something, you instead remove it successfully, but then don't worry too much about the pointer by setting it something new. So if I was to delete this array, then this will go and deallocate this space and reclaim it so that the system can use it again. But if you don't overwrite this like we have been doing in our code, then this is just pointing to nowhere in particular, and if you try to use it, it's going to be bad because it's not pointing to data that you're allowed to use anymore, and your program will crash. It will segfault. If you ever do this, this is called a dangling pointer. It just means that it's pointing to something that's not there anymore. The general solution for this, if you're not planning to set it equal to something new, like a new array allocation, for example, is to just set it equal to null or null pointer, just as a signifier that it's not pointing to anything anymore. You'll have it just point to the symbol null, which is just the number 0 in C++. It's just like a sentinel. You use it to mark that you don't have anything there. So that's a dangling pointer. If it shows up on the test, that's what that means. I guess with regards to memory management, I also wanted to talk about a function that exists and then kind of how we can get around memory a little bit more in detail. Oh, that erased everything. I guess that's not a big deal. So I guess I've been talking just in general. I've been kind of like waving my hands about it. But when I do something like this, we said that memory is split up into individual cells called bytes, which are 8 bits. They're just 8 zeros and ones. Different data types have different sizes. A character is 1 byte. A integer and a float on modern machines are 4 bytes. And then a double is double the size of that, and that's what a long is for an integer, are 8 bytes. I guess a Boolean is probably also 1 byte. And a string, depending on the language, is either 8. I guess it's technically both. It's either 8 bytes or variable being however long the string is, because it could be anything. The 8 part comes in as just the fact that all pointers are 8 bytes on modern hardware. If you've ever heard the fact that you have a 64-bit machine, that's kind of what it's referring to. You have 64 bits for memory space, which is 8 bytes. All pointers are going to be 8 bytes. And a string, if you remember, is a character pointer, and that's why it's 8 bytes. But the actual contents of the string is variable, because, you know, hello world is going to take up more space than just hi. But we said that these go into memory and they take up how many other spaces. So if I did an allocation of a variable called x, it's going to go into memory and pick 4 random contiguous blocks like this. And it's going to say those are x. And I could do a character. Let's just say A, and it's going to go into memory and allocate 1 block. So all these data types are different sizes, and even the ones that are same sizes have different representations. Like you can't just directly say a float is an integer just by changing the data type. It actually has to do some sort of conversion because they're represented differently. If you ever want to find this out, or you are ever uncertain. So we've always said avoid magic numbers in these classes. With these, you want to do the same thing. Integers now are 4 bytes, but maybe 100 years in the future, they might be 10 bytes because we have excessive amounts of memory in our computers because it's like really cheap or something. Then you can use the operator called size of to figure out how big a thing is. And size of takes a data type. If I said size of int, it would return on my machine a 4, hopefully. So these are the size of these things. If you were to use the size of function, it would tell you each of these numbers. And this is just because hardware is constantly changing, and these data types might be different if we get more space. C++, I think, was invented in like the 70s, 80s. So you can imagine computers have changed a lot since then, and it's good to do this just for legacy reasons for your program. You might want somebody to be able to run your program in 20 years on a computer that's more powerful, amongst other things. So you can use this for some other things as well, like telling the size of a dynamic array after it's been allocated or something like that is totally fine. Just something to keep in mind is that that exists. I don't think we'll ever use it in this class, but it does exist. And the other last thing I wanted to bring up, which we've talked about before, is dynamic array traversal. I try to write them in the intuitive way. Actually, let me allocate this first. New int 4. This goes and makes 4 integers in a row with indices 0, 1, 2, and 3, and they're all right next to each other. And the way I've been telling you to access these, even after dynamic allocation, is just do it the way you would do a normal array. So this would go to here, let's just say, because I think that's easy to read and it's what you're used to, and I would just do it that way. But as a reminder, I think we very briefly talked about it, but you have the ability to access this using addition as well. So this and this are also viable options to access the first element. You would have to dereference it because this is a pointer, but you can also do that. Just consider when you use a pointer and you add numbers to it, it hops that many units forward in terms of whatever that data type is. So array is pointing to right here, but when I say array plus 1, I'm talking about the next memory address that's 1 space over. And if I said array plus 2, I'd be talking about this one right here because it's 2 integers over. Like it's that many blocks over of these cells. Will we have to add in hex or decimal? Preferably decimal. There's nothing stopping you from doing hex or octal or whatever you want. This is technically valid, but I guess just to clear up maybe what your question is, it would be the hex representation of the decimal number. So this is 1 in hex. I guess I don't even need the 0. I could just put 1. You aren't putting a memory address if that's what you mean. You're putting the number to skip by. So I can't just like do this and like, I don't know, let's say I had another pointer to another array that's also probably going to be printed in hex. This is not allowed. You can't do that. This is a no-no. But it will convert, and it understands what you mean when you just put normal numbers. It understands it as being cells of memory to jump over. So in this case, if it's an integer pointer, it's going to jump 4 blocks at a time, 4 bytes at a time. Or you can think of it as 1 block of an integer is 4 bytes. So it hops 1 integer at a time. It's kind of just dependent on your type. As a final note, just remember also on that because we can access things in addition, then R, which is the same thing as array plus 0 technically, refers to the first element. even though R is the name of the pointer pointing to our array, the beginning of the array is technically the first entry all the time. So if you dereference a pointer to an array, it's actually just going to give you the first thing. And it's not going to stop you from not doing it, which it probably should, because I think most of the time you don't really mean to access that if you're typing that. It's maybe just a typo. It's not going to stop you. The compiler is just going to let you go ahead, and it's always going to return the 0th thing. So that's another thing to be careful of. But yeah, we have the ability to, as a reminder, add numbers to these, and it will go to that position in the array as well. You can also use that to technically like update a pointer and traverse the array. Just consider that like that's maybe not the best way to do it, because if you update this, you're gonna like lose track of where the beginning is unless you keep track of a way to get back, and that's just a lot of work. But I did notice there were some questions about this on the test, and I wanted to be sure that everybody remembered this because I think I just did it in passing. I don't think this is a good way to program. I don't think it's very readable, but it is totally allowed in C++, so just be aware that it exists. On that note, I think we're at the end of class. As always, I will stick around if you have any questions. Assignment 4 is due this weekend. I'll probably move it forward, and then I think that's about it. So I will see you guys next week.